Alright guys, we're going to start working on the application problems on page 217. I'm sorry for the noise in the background. I cannot figure out why we get that noise from the computer. In the past we haven't really had that shh sound. So just bear with me here. Application page 217. The first problem is an aircraft travels 1,000 kilometers west and then travels 500 kilometers west. What is the total displacement? Remember, displacement is the total change in distance, or delta x, where you take your final position and you subtract the initial position. And so even though this person traveled, if we just make a drawing here and we say west is to the left, we say the person traveled 1,000 kilometers to the west first, and then they traveled another 500 kilometers. What you do is you take your initial position, which is right here, and your final position. So in this case, you're just going to add up these two distances. So we get a total of the x final, if we look at it, is to the left. Is to the left 1,500 kilometers. And then that's the final position. And the initial position is 0, because this was 0 here. So we actually have 1,500 kilometers. Let's look at problem 2. A vehicle travels 60 kilometers north and then 40 kilometers south. What is its total displacement? Let's do a drawing of this again. And we have a person. They're going to go 60 kilometers north. And then they're going to come back 40 kilometers. So the way to figure this out is, you know that the total displacement is only from this distance here. This total distance here, the difference between the two. So we actually just take 60 minus 40 and we get 20 kilometers. Because they traveled in one direction and then they traveled back in that same direction. So the total displacement would be 20 kilometers. Let's look at 3. We have a boy who walks 100 kilometers forward. We'll just draw it like this. 100 meters forward, then 150 meters back. 50 meters back. So what is this total displacement? The displacement for this one, you would say that it's actually 150 meters minus 100 equals 50 meters. But I forgot to mention on the other problems that we need to give a direction. This would be 50 meters backwards. In the previous problem, 20 kilometers, what is the total displacement for problem 2? It would have been 20 kilometers north. Let's look at problem 4. An airplane travels 800 kilometers east. I'm going to draw that like this, 800 kilometers. And it's often very helpful to draw these diagrams. And then 600 kilometers north. 600 kilometers north. So we have 800 kilometers and 600 kilometers north. What is the total displacement? Well, remember, this is east, this is north. Well, we learned from class that the total displacement is going to be drawing this line here. How are we going to figure that out? Because the total displacement is not 800 plus 600. you want to figure out what is the total distance from your original point to the final point. And this is where we have the Pythagorean theorem come in. And this is where we know that if we label this side A and side B and side C, that we have an equation that says a squared plus b squared equals c squared. So to solve this, A would be 800. We would go 800 squared plus B would be 600. 600 squared equals c squared. So let's do this with our calculator, and we actually get 640,000 plus 360,000 equals c squared. So let's add those together, and we actually get 1,000,000 equals c squared. Well, in order to solve this, you have to take the square root of both sides, if you remember from our class. And we just take the square root, again using our calculator, and we actually get 1,000 equals c. So our total displacement here would be 1,000. And they also ask for approximate direction. In this case, we would say northeast. So our answer would be 1,000 kilometers northeast. Okay, the next problem we're going to do is application on page 218. And if you ever need to stop the video to go a little slower, that's completely fine. Now, the question is calculate the average speed of a car if it traveled 180 kilometers in 2 hours. So the total distance, delta x, equals 180 kilometers. The time, delta t, equals 2 hours. Now remember, average speed from our class, speed equals delta x divided by t, or delta t. So in this case, speed would be 180 kilometers divided by 2 hours, and our answer then would be 90 kilometers per hour. See how I keep the units? Kilometers divided by hour is kilometers per hour. That's problem 1. Problem 2 says if an airliner travels 920 kilometers per hour for 2.5 hours, what is its total distance traveled? So this one, it has a speed equals 920 kilometers per hour, and it went a time, delta t equals 2.5 hours. So the question then is, what is the distance? They want to know delta x. This is an algebra problem. Maybe you guys aren't at this point yet, but in order to find delta x, you need to remember this equation, delta x equals the speed times delta t. So in this case, we have 920 kilometers per hour times 2.5 hours. So whenever you multiply these together, you see I have the units there. I'm going to take this unit, and that's going to cancel out. So now we have 920 kilometers times 2.5. And we just take our calculator, and we get total distance (2,300 kilometers). Let's look at problem 3. Again, we're on page 218. The question is, what is the average speed of a race car in kilometers per hour if it travels completely around a 5-kilometer track in 1 minute? Now, this is a little bit more difficult. So it's going to go around a track. Total distance is going to go 5 kilometers. And the time it takes is going to be 1 minute. So 5 kilometers equals delta x. Now, it wants to know the average speed, and the speed is delta x divided by delta t. So in this case, we would have 5 kilometers divided by 1 minute. But they actually asked that we do this in kilometers per hour. So now we have to do some unit changes. We have to remember how many minutes there are in an hour. So in order to do that, we just write the conversion factor of 60 minutes divided by 1 hour, because there's 60 minutes in 1 hour. Now that would cancel out the minutes there, and then we would end up with 5 times 60 divided by 1 hour, so we would end up with 300 kilometers per hour. So the tricky one with this is using the unit conversion, 60 minutes per hour. Problem 4. If a car travels 100 kilometers in 1 hour and another 200 kilometers in 1.5 hours, what is its average speed for the entire trip? Now this one I'm actually not going to have you guys do because it's having you average out the speeds, and I'm not too worried about you doing this one. So let me go ahead and do it. And see if you guys can understand this a little bit. A car travels 100 kilometers in 1 hour and another 200 kilometers in 1.5 hours. What is its average speed for the entire trip? So the total distance traveled would be 100 kilometers plus 200 kilometers equals 300 kilometers. And the total time, delta t, is 2.5 hours. So all we have to do is take our distance divided by the time. So we have 300 divided by 2.5, and we get 120 kilometers per hour. Let's go to application on page 220, our final application section. If an airplane undergoes a displacement of 500 kilometers northwest in 1.2 hours, what is its average velocity? Remember, velocity or speed equals delta x divided by delta t, or t. And we have the total distance in the problem of 500 kilometers, and the total time is 1.2 hours. So the speed would be 400, you divide that out, 500 divided by 1.2, and you get 417 kilometers per hour. And the approximate, remember, for velocity, they want to know not only the speed, which is 417 kilometers per hour, but also the direction, because it's a vector quantity. And the way to know this is which direction it went. It actually told us in the problem. It went northwest, so we would just write northwest down. So the answer would be 417 kilometers per hour northwest. Problem 2, if a car travels 12 kilometers south and then 5 kilometers north in 0.25 hours, what is its average velocity? This one is a little bit different in that we need to figure out the displacement. So we have the speed is delta x divided by delta t. Now, the total distance, remember from our earlier problems, if we draw a diagram and we go 5 kilometers or 12 kilometers south, and then we go 5 kilometers north. Our total displacement is 12 minus 5 equals 7 kilometers. So in this case, we have 7 kilometers divided by the time, which is 0.25 hours. So the speed, if you do that calculation, 7 divided by 0.25, you actually get the speed equals 28 kilometers per hour. And that's just the speed. If we want the velocity, which is given with a vector quantity with the arrow over the top, which direction was that? Well, that's the south. Because we ended up, if you look at our displacement, we started here, we ended up to the south. And finally, for number 3, actually, that was now, if we look at that one a little closer, it asks for the velocity, which we already gave, 28 kilometers to the south, but then it also asks for the speed. What was its speed? Well, the speed's a little different. You're going to take the total distance traveled, which would be 12 kilometers plus 5 kilometers equals 17 kilometers. And then you're going to divide it by the time. So you take 17 kilometers divided by 0.25, and this is the speed. And it's going to be 68 kilometers per hour. Now, this is a lot different. The difference is that speed takes into consideration all the distance that you went. But velocity, right here, just counts the displacement, where you ended up. And you didn't end up very far from where you started. But the speed took into account the fact that you went one direction for a while, and then you came back a little bit. Let's take a look at problem 3. Calculate the magnitude of the resultant velocity of a canoe if the speed of the current is 8 kilometers per hour and the canoe is paddled across the creek at 6 kilometers per hour. Now, this is a little bit difficult one, and it's really interesting because what we have this current. I'm going to draw the current here, and I'm going to push the current this direction to the right, and we'll say that current is 8 kilometers per hour. That's the direction of the river, and I'll just draw it like this. It's going like this, and you're trying to get a canoe across, and you're going to go this direction. Here's your canoe, and you're going to try and go this direction, okay? And you're going to paddle at 6 kilometers per hour. Okay? And they want to know what is your speed or velocity of this when you're in the canoe. Well, the way to figure this out, remember, if you're going to try and go directly against the current, you know that you're actually going to travel, as you're trying to travel to the other side of the river, let's put the shore here and the shore here. If you're traveling, you're going to head straight across, but what's going to happen is your canoe is actually going to go like this, to the right. So the way you calculate that out is you actually have a vector going for 8 kilometers per hour in one direction, and then you have your vector in this direction at 6 kilometers per hour. And so the resultant vector, like this, is the actual velocity or speed that you'd be going. So you have 8 and 6. And this comes back again to our Pythagorean theorem, where we have a squared plus b squared equals c squared. So in this case, we have a, b, and c. And we want to know what c is. So a squared would be 8 squared. B squared would be 6 squared equals c squared. Well, this would be 64 plus 36 equals c squared. And that would mean we have 100 equals c squared. In order to get c on its own, you have to take the square root. So we have 10 equals c squared. So our answer actually is 10 kilometers per hour. That's the actual speed that canoe is going to travel as it travels across the stream.